In the last lecture, I introduced futures and asynchronous code. And I want to make really sure that we all are on the same page regarding what this means and what async code really is. Asynchronous code is code that runs and might take a bit longer and that shouldn't stop our code from continuing. So the result of such asynchronous code will be available sometime in the future, but not immediately. And here's an example. If I have a variable result, and that's 1 plus 1, then the result of this calculation of 1 plus 1 is immediately available. When Dart parses this line, it doesn't need to wait for this. It's immediately available. Of course, it needs to calculate this, and all these calculations take some time, but we're in the sub-millisecond area there. And therefore, this is available immediately. There are other operations, for example, sending HTTP requests, which take a bit longer though. You don't know how long they take. They might still be very fast, but they might also take way longer. And therefore, it would be bad if we wait for such a HTTP request result, because the other code would not continue executing in the meantime, and your application would basically be frozen. So instead, for such operations, what Dart and many other programming languages as well do is they register some function that you want to execute in the future once the response is there, and then they continue. And they just keep that to be done, to be executed function in mind, and once your async operation finished, once that HTTP response is there, for example, they remembered that they had this function saved and they then executed for you. And Flutter handles all of this with a class that's baked into Flutter, the future class, which has a fitting name if we consider that it's about handling results in the future. You can also create your own futures. Future has a constructor, and to this constructor you can pass a function where you, for example, return hello. Now let's store this in a myFuture variable, and now this creates your own future, and this is not the function that will be executed in the future, but instead this will be executed right away by Dart. When it encounters this future, that you create a future, this is what it executes right away. In here, you could write your own code that takes a bit longer. For example, because you're setting up a timer, or you're writing your own HTTP library where you do all the low-level things of composing the request and sending it over the wire and parsing incoming response bytes. That's in the end what packages do for you behind the scenes. You rarely create your own futures. Here we are doing it though. So this is now executed immediately by Flutter. Of course, this is no code that will take longer, but still, Flutter will go ahead with our code first, and only once the other code, the synchronous code, has all been parsed, it will basically check if that is done, and of course it will be done by then, because it will also finish immediately. And then we can use myFuture then to register a function that should be executed when this future is done. Now again, this will be done immediately, but Flutter does not stop all other code execution just because this is done. Instead, it will finish the current code execution go and finish all the other synchronous code first, and then check if the future is done, and yes, it will be done, and then it will call the function you passed to then. So here you might get your result, and in our case that will be a string, and here we can then print result. If we now hit run here, we see hello. Now the interesting thing is that if I add this runs first here, and I add another statement here, this also runs before the future is done. If we add all of that and I hit run, then we see that these two statements indeed run before we see hello. Now that's really important to understand in what I just explained. We create our own future here. This function is executed right away by Dart, not in the future, but right away when it finds this line. But Dart expects that this function does something which takes a bit longer. So of course it will also execute this code, but it will simultaneously, so to say, continue with the other code. Now of course this is done immediately, but Dart doesn't care. It continues with the other code. Here it sees that you're using the future and you're setting up a function that should be executed once that code in the future is done. Now, Dart doesn't care that this is already done. It still continues with all the other code, and only once it's done with all the other synchronous code, it goes back to your future and checks, is this done? And yes, it's done, so then it executes this function. That is how you can think about that. Of course, technically behind the scenes, it's a bit more complex, but in the end, that is how you can think about this. Now, as I said, you rarely create your own futures like this. Often you have some packages like the HTTP package, which have some methods that just return futures. So in this case, you wouldn't see that part where the future gets created. You would right away be at that part where you use then to register the function that should execute once this future is done. So that's the more common scenario of how you work with futures. You get finished futures and you just start at this step here where you register a function that should be executed when the future is done. Now this function here, as you see, gets a result, the result of the future, even if the future doesn't return anything. So even if you have a future like this, you still would get an error if you don't register a result or expect a result. So you should always expect a result here, even if you know that your future won't return one. Then you just, well, don't have one, but still you need to accept one here. And in addition, it's also worth noting that then also always returns a new future. So you could add another then call after this, and this then block is effectively called on the result of this then block, which is a future. So then always returns a new future, which will be done as soon as your code in the first then block is done. So here we would have another round of code execution. So here we can simply execute another function after first then, which executes, well, after the first then block is done. So we could add this code snippet here and run this. And now we see ... that's the output of the first then block, and then after first then here. And you can add many then blocks as you want. You always get a new future returned automatically. Now, of course, you don't have to add one if you're, well, got no other code to run. You can just ignore that future, but there always is the opportunity for you to chain more then blocks after each other. So this concept is called chaining, that you call a method on the result of a previous method all in one line. And that is simply a powerful feature which would allow you to do multiple different steps, which possibly all take a bit longer, and then always use the result of the prior step in your next step. Futures can also fail, and we can also write this in a more readable way, by the way, to make it clearer that this belongs together but runs after each other. Now, futures can, by the way, also return errors, and you can handle those with catch error. Now you'll see that throughout the course. Here you get the error that was thrown in the end, and then here you can do whatever you need to do to handle that error. Send it to your own analytics server, show an error message to the user, whatever you need to do. It is worth pointing out that catch error also returns a future, so you can call then after catch error, and then this then block here will execute if we had this error here. Catch error will catch any errors thrown by the future or by any then block in front of catch error. It will not catch errors thrown in then blocks after catch error. And these are the basics about futures and async code. It's an important concept which you find in all major programming languages. It's not always called future. In JavaScript, for example, it's called promise, but the idea always is the same. You have some code that might take longer, so to not block execution, the programming language continues with the other code, and your code that depends on that longer taking operation is registered and executed once that operation is done. Now we'll work a lot with futures throughout the course. You'll also learn about a different syntax than using all these then statements, and therefore this will become clearer and clearer over the course, but I hope the fundamentals are clear right now.